Okay, welcome back to another episode of Beginning Algebra. And in this place, we're going to be at solving systems of equations. But unlike last section, which we were graphing, last section and seeing if they touch, we're going to do the algebra. And we've skipped over the one that's called substitution method. And we're going to go right into 4.3, which for our textbook, 4.3 is what's called the elimination method or the addition method. Don't worry about the substitution. We just didn't have enough time and we can get through it without it. Now I want to show you something with some of the last problems that we did. And if you recall, we graphed problems that look sort of like this, where it says solve, and solve by graphing. So I'll say recall. What we'll end up doing is get it in slope-intercept form, y equals mx plus b. We want everything right here into y equals mx plus b form, because it's so much easier to look at. Okay, so solving this one for y. Okay, we get that one, and we can graph that one in a moment. And solving this one, I think maybe we'll start off with subtracting x from both sides. So that leaves me negative y right there. And what we're going to do is subtract x. And then what we're going to do is have a plus 2. And then the next thing what we're going to do is get rid of the negative sign on the y. So we're going to go y equals negative x plus 4. And this one here, what we want to do is get rid of the negative. So we're going to multiply by negative 1 everywhere. So what that leaves me with here would be positive y. And don't forget to switch the sign here. And don't forget to switch the sign here. So now we're looking at a completely new looking set of equations, which really was the same as this, except I can graph this so much easier. This is your x-axis. This is your y-axis. Maybe what I'll do this one. I'll do this one in red. And I have to find 4 first. So let's see. 1, 2, 3, 4. 1, 2, 3, 4. So this would be, according to this, would be 4 y-intercept, and the slope. The slope right here, m is equal to negative 1 over 1. So we go down 1 and right 1. Connect the dots. And we've got our first line. The next one, I think, is what I'll do is I'll do this one in green. So I start at negative 2 this time, which is down here on the y-axis. It's a y-intercept, negative 2. And the slope right here, m equals 1 over 1. So up 1, right 1. Up 1, right 1. Connect the dots. And notice that these things are going to touch. It's going to touch somewhere in here. This is your solution. Solution. That's your solution, and guess what? Your job is to try to guess what the answer is. And since I just did this by a sketch without a really nice grid, it's going to be hard to find it. Well, not impossible, but harder to find it. You can kind of guess. It might be 3, 1. Might be 3, 1. Let's go back up here. I wonder if 3 and 1 work. That one does. I wonder if 3 and 1, 3 minus 1 is 2. I got lucky. I kind of guessed it. So this is 3, 1, or x is equal to 3 and y is equal to 1. This is your solution. And if the whole point of that one is make sure you do your graphing on a really nice grid. And then I wouldn't have to really do a kind of a guess. I'd probably figure it out quickly. Well, the method that I'm going to show you, which is in 4.2, the method I'm going to show you at 4.2, excuse me, 4.3 in section 4.3, which is on elimination method. We're going to find the same x and y algebraically, but we're going to do it by what we call eliminating one of the variables. And you have to set it up in a very special way. You want the original problem, if it's not already, in standard form. You want it to be in standard form. So let me bring this up and take a look at the original. Okay, here's the original problem. See right here? And sure enough, hey, this is already in standard form. Don't worry about this being in 4.2. I just wanted to show you an example. But you could have written it down and on your separate scratch piece of paper. Yeah, this is in standard form where the variables are on the left-hand side of the equal sign. So we're going to line up the x's and line up the y's. And if possible, and I think you can see this, hopefully you can, if possible, when you add straight down, one of the variables disappear, namely the y's. Y subtract y is gone. That's what we want to happen, to add straight down and make one of the variables go away. Now this one was conveniently set up. I'm going to show you this in a moment. I'm going to go to 4.3's instruction now, and we'll kind of go through it step by step of what we're supposed to do. We'll come back to this one before we end the session. So in 4.3, as I said, we're doing elimination. Sometimes we call it the addition method. And if we look at this set of equations, both of these are actually in what's called standard form because the x's are first and y's. X's and y's on the same side of the equal sign on both of them. That's the first thing. Get each equation in standard form. X's and y's on the left side of the equal sign or the equation. Then we choose one of the variables to eliminate. Now, if you look at this one in comparison to the other one, if we add straight down, they don't go away. So it's some work that we have to do on this. This one is not as easy as the one that I did with the graphing. To do this, we're going to get the numerical coefficients of the variable we want to eliminate to be the same thing, but we want opposite signs. Okay, here's the idea. What's the numerical coefficient of this one? 1, and this was -3. Well, they're not the same. We want them to be the same and opposite signs. Now, they already have opposite signs, but they're not the same number. Likewise, with the y's, they're opposite signs, but they're not the same number. But we're going to create the same number. Well, I'll show you how to do that. So here's our problem back here. Let's choose. You might say, well, which variable do you pick? Well, in this case, it doesn't matter. Just pick some. I'll pick x just because it's first. Choose x. We want to make the numerical coefficients to be the same, and the signs are already opposite. So what number would be nice, like a lowest common denominator or a least common multiple, sometimes we say? What number could I use that 3 and 1 will go into evenly? 3. That's the smallest. So this would be nice if this was a +3 and that one's already a -3. So on the next page, you're going to see how I'm going to do that. So here's the original that I had without the parentheses. I'm going to multiply what I want, the x, to be by 3. But what you do to one piece, you have to do all of it. That's why the parentheses are on. So multiply it by 3 here, and then we distribute. And then you're going to distribute everywhere, which leads me to this step. And here's the second one already. And now we notice they match up, meaning 3x minus 3x is 0. That's what I wanted. I made the x's go away. I've eliminated the x. These two pieces, negative 7y, add these two straight down, you get negative 35. And now you've got a little equation that you're trying to solve for y. And in this case, you're going to divide by negative 7. So you end up with y equals 5. So what that is telling you is when you graphed, if you're able to graph it, and you graphed it, and the two lines, they touch, where they touch for the y part, it's going to be 5. And now your job is just try to figure out where the x part, where they touch. And that's where we're going to talk about plugging in the 5 into either one of the original equations. Just plug in the 5, this one here, to one of the originals. One of the originals. Well, here's the original, just to remind you. See, this is the original. Pick one of these, and it doesn't matter which one. I usually pick the first one. There it is, the first one. So I'm going to take y equals 5 and shove it right there where the variable is. So there's what I did right there. Simplify, add 15, and notice you get a number. There's your variable x equals negative 3. So it turns out when x is negative 3, y is 5 is the place where those lines would touch. And by the way, a little side note, what quadrant would that be in? X is negative 3 and y is 5. Yeah, that looks like it'd be quadrant 2. Quadrant 2. Now, with that said, that's one of the harder ones that I just did. Let's see if I've got any easier ones to begin with. Let's go back to that original. I'm going to do it right now. Let's go back to the one that I did, which was right here. Let's go back to this one and do that in substitution. I found the answer by graphing. See, here's the answer by graphing right here. We just did that one. See, there it is. So now I'm going to go ahead and do this by elimination method, not by substitution elimination. And what's really nice is the y's will go away when you add straight down. And here you get 2x. And over here you get 6. And now you just have to divide by 2, or namely x equals 3. Now, if you go back to the graph part and you take a look at the place where they touched, the x was 3. See, right here. The x was 3. See, right there. X was 3. You just got to figure out what the y is. I know it's 1. But from here, what's the y? You plug, use the word plug, this into either original equation. So how about pick the first one, just because I always pick the first one. So I'm going to plug 3 in right here, 3 and 4 right there. So that's 3 plus y equals 4. Gosh, it has to be 1. It has to be 1. Which was the ordered pair that we got from graphing. See, 3, 1, 3, 1. So sometimes they're easy like this one, and sometimes they're harder like the other one that I had worked out from the beginning. Okay, let's try another. This one's not so bad. See that? If I just add straight down, the y's will go away again. And I'm left with 2x equals 18. Divide by 2. X equals 9. Plug this into the original. Let's say the first one. So that would be 9 plus y equals 13. And of course, y's got to be 4, but you could subtract 9 from both sides. So you get y equals 4. So there's your y, and here was your original x. Remember, it's got to be in standard form in order to do this. Is this in standard form, the next one? the variables are in order from left to right and on the same side of the equal sign, it is. Now we just want to make and decide which variable to make go away. And this one is not like I can just do the one up here, just add straight down. Let's pick the x's again. Let's make them go away. And in order for that to happen, these would have to be the same number, which right now they're not, but they'd have to be the same number and opposite signs. They're already opposite signs. So how about if I made this a 2? And if I wanted to do that, I simply would make a 2 on the outside and then distribute the 2. Here's the original first one. And now when I distribute the 2 over there to everything, I'd end up with negative 2x. And don't forget the 2 times 4, which is 8. I almost messed that up, but 8y. And then don't forget the 2 times 17, which is 34. And now at this stage, you can just add straight down, which notice those will go away. Negative 1 plus 8 is positive 7y. Negative 6 plus 34 is positive 28. Y's got to be 4. 7 times 4 is 28. Y's got to be 4. So then you plug y equals 4 into one. Let's do the first one of the originals. And then solve for x. Ultimately, it looks like it's negative 1. And if I wanted to know if this really was the answer, you take both the x and y, and you would have to check, not just one of them, you'd have to plug it into both of them and see if it's true. Because if it was false for one of them, then either one of two things happen. If it was false for one of them, then this isn't the right answer because it has to be true for both. Or you plugged it in, you messed something up on the check. And that happens to most of all of us at some stage. All right, let's see if we can do one more. Okay, let's take a look at this one. Let's look at making the x go away. So let's make this a 3 here. So that when I distribute the 3, don't forget, give the 3 to all 3 pieces. Add straight down. That's 0. That's 0. You might think you made a mistake, but we didn't. And of course, this equals 11. So it looks like we got 0 equals 11. So what happened is the variables disappeared, and it's false. This is telling you something, that the lines are parallel. It's telling you that there's no solution. I'll say it again. If the variable went away, which it did, there's no variables at all, and this is false, of course it is, then there's no solution. There's no solution. You know, check it out. If you want to go back and graph it, you'd find out that the slopes would be the same. The lines would be parallel. Check it out. Okay, and the last one I think I have right here. Let's make the x go away. So I make that a 4 again. So let's multiply by 2. So that the top one would be 4x. So I can make the negative go away, and make the x's go away. And then plus 10y equals 2. And here's the second one right here, which is negative 4x. Subtract 10y equals negative 2. Add straight down. And in this case, everything goes away. You have 0 equals 0. And maybe you can guess what's the answer to this one based on the graphing. Let's see. On the graphing part, you had one answer, you had no answers, and then you had what? Infinitely many. If you graphed both of these, they'd be the same line. This is telling you when the variables disappear, and it's true, this is true, then it would be infinite solutions. Infinite solutions. So, summarizing, systems of equations, all you're going to get is two equations with two variables, and they're going to be lines. If you wanted to graph them, you're just seeing if they touch, and if they touch, guess the answer. And check it. If they don't touch, they're parallel, there'll be no solution. Now, if you had the equations and you didn't want to graph it, then you can do this by this elimination method. Make sure that you end up getting it in standard form, and then figure out which variable. I usually pick the x oftentimes. Make one of the variables go away, and sometimes both go away, and that tells you some special circumstances. But if you make a variable go away and you solve for the other variable, then you're going to find that there's a point of intersection, and that ordered pair that you'll end up finding algebraically is the place where, if you graphed it originally, that's where they touch. So, one answer, no answers, infinitely many. And this is the algebra way that I'm teaching you. Okay, hope that helps. Take a look at the author. He's got about, I don't know, probably half a dozen different ones to try. Check it out, and then send me a message if you're stuck, and I'll see how I can help you. Otherwise, be safe, and see you next time.